Hey geometry class, this is our lesson for section 6.1, and what this section is going to be talking about is similar polygons and how to identify similar polygons and then some of their properties, and we're going to solve some problems. But what you'll see in this chapter, just warning you right now, is some of the same things or similar things that we saw back in chapter 4 when we proved two triangles congruent, like we had angle, angle, side, side, angle, side, and side, 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 those congruent postulates. And we'll discover more of those types of postulates and theorems in this section too that prove two triangles similar rather than congruent. So let's go ahead and get started on this. Okay, to start us out in this section, we're going to look at the definition of what similar is. So figures that are similar, and this is how you denote similar, and we'll see that here in just a little bit, have the same shape, but not necessarily the same size. So two figures that are the same shape and size are congruent, but ones that have the same shape but not same size are called similar. Okay, let's look at these examples here. Okay, so in this one, you can see, well, if I had angles marked and stuff like that, it says triangle 1 is similar to triangle 2, and this is how you denote it right here. That means the same thing as this statement right here. Okay, compare it to these two triangles. Okay, these two triangles, triangle 1 and 2, they have the same shape, but they are not the same size. These two triangles do not have the same shape. They're definitely not the same size either. So this is how we would denote not similar, is with the symbol of similar, but with a slash through it, just like you would say not equal to, is that right there. Okay, so let's look at something else here. Okay, here's how we define similar polygons. So if two polygons are similar, if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. So on this diagram right here, I have that ABCD is similar to EFGH. Okay, and it's already has their angle markings marked. So angle A is a right angle. That corresponds to, let's just go in order. Angle A corresponds to angle E, and they are both have a right angle. So they are congruent. And then let's look at B. B is congruent to F. You can see that they both have the same congruent marking symbol. They just have a one little arc thing right there. So B is congruent to F. And then C and G, they are congruent, marked with the same congruent symbol. So we got that statement. And then D is another right angle, and so is H. And those two are congruent. So if all the corresponding angles are congruent in the figures, and these figures have their corresponding side lengths are proportional, and I'll show you what proportional means. It's this next part in the statement right here. So we can say that AB, side AB, corresponds to side EF. Okay, and if you don't understand what I mean by corresponds, well, look right here. In our statement of ABCD is similar to EFGH. The first two letters in this thing, that segment right there, AB and EF, those will correspond to each other, and they'll go in the same order as we have written our similarity statement here. Okay, so AB and EF write as a ratio right here, AB over EF. That if these two figures are similar, then this proportionality statement will be equal to this first one. So look at this. AB is proportional to EF, and then let's see, BC, FG, put that as a ratio, then CD and GH, that's right here, and then DA and HE. All of these right here are the corresponding side lengths just put in a ratio like this, AB over EF, all their corresponding sides. And if you calculate all of these, like 6 over 12, well, that's 1/2. And BC, let's see, 5.4, sorry, over 10.8. That is also 1/2. If you don't believe me, put it in your calculator. It'll show you that it's 0.5. And then again, 4 over 8, again, that's 1/2. And then 5 over 10, that's 1/2. So all of these statements right here, all their corresponding sides are proportional and they're equal to each other. So that is how we're going to prove two polygons similar in this section so far, is that all their corresponding angles are congruent and all of their corresponding sides are, well, all their corresponding side lengths are proportional, meaning their ratios are all equal to the same number. Okay, so let's look at an example. Okay, for this first example, it says list all pairs of congruent angles for the figures, then write the ratios of the corresponding sides in a statement of proportionality. All right, so let's look at this first portion. List all pairs of congruent angles for the figures. Okay, so just like I said before, in this statement, this is how we're going to look at the angles. A is going to be congruent to D. B is going to be congruent to F. And then C is going to be congruent to E. And if you look at the shapes, you'll notice that, yeah, this is congruent to this. And then, let's see, B and F. These two are congruent. And then these two are congruent. So write that as a statement, like list all of these pairs together. And this is how I'm going to tell you to list it. So angle A is congruent to angle D. Angle B is congruent to angle F. And then angle C is congruent to angle E. And we're done with that. So this is how I want you to list all congruent angles right here. And then to write the ratios of the corresponding sides in a statement of proportionality, this is what I'm wanting you to do. Similar to how we labeled all of the angles going in order according to this statement up here, I want you to do that again. So AB and DF. AB over DF, that is equal to the next segment, BC, so BC, EF. And then the last one is going to come from this letter, then this one, the last and the first. So CA over ED. And this is the statement of proportionality that we need to show here. So both of these are statements that we need to show that two triangles or two figures are similar. Okay, now let's look at this one over here. We have polygon WXYZ is similar to PM or MNOP. So on this one, do the same thing. List all the angles, the corresponding angles that are congruent to each other. So angle W is congruent to angle M. Angle X is congruent to angle N. Angle Y is congruent to angle O. And then angle Z is congruent to angle P. Now let's do the statement of proportionality. Since there are three sides in a triangle, there should be three statements that you should make for proportionality here. If there's four, like we have here, four sides, there's going to be four of these ratios that we put together. So let's start at the beginning, WX and MN. So WX over MN, that's equal to the next one, XY over NO, and then YZ over OP, and then lastly ZW over PM. There you go. That is what these directions are telling us to do, is make these statements right here that we just did. Now we're going to look at this multiple choice problem. It is telling us that triangles ABC and DEF are similar, and then which statement down here is not correct. So let's look at this. ABC and DEF. That's not the same thing as what we had up here. It says ABC and DFE. Okay, so can't use these statements up here for these two triangles because it states them. These letters are in a different order than these right here. All right, so looking at this statement, we have AB over DE. Okay, those two sides do correspond to each other. And then BC over EF. So AB, DE, then the same second set, BC over EF. Well, that one's right. So that one's not our answer. Now let's look at the next one. We have CA, so this statement, CA over FD. Okay, that works. And then AB, AB over DE. AB, DE. That statement works too. Now let's look at this last one. It says angle A is congruent to F. Well, in the statement, if these are going in order, angle A and D are the angles that should be congruent to each other. So our answer to this one is C, because angle A is not congruent to F. Okay, so let's look at our next problem. Now on this one, you'll see something like these problems in your book. It says determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. Okay, something that we have not talked about is the scale factor, and I will show you that in one of the problems here on how to find the scale factor. Okay, so in the first one, it says determine whether the polygons are similar. Well, to determine if the polygons are similar, remember, we have to know that all corresponding angles are congruent, and then all their corresponding sides are proportional. And let's look at this. We really can't determine much of anything from these angles. We just know B and C are congruent to each other, and then E and F are congruent to each other. So let's go to the side lengths. Let's make it a statement of proportionality here. We can say AB corresponds to DE because these triangles, they look similar, so let's see if they are. Let's see, 5/6. It should be equal to, well, this other side, 5/6. That's true. It's the same numbers. And then this side over here, BC, should be over EF should be equal to. So let's see, 3/4. Well, 5/6 is not equal to 3/4. This last part of our statement right here makes these two triangles not similar. So we're going to state that ABC, say triangle ABC, is not similar to DEF. And we're done with that one. Okay, let's look at this next figure. These two, we can definitely tell that all of the angles are congruent. All of these angles in WXYZ are 90 degrees. And so it's the same thing for ABCD. We have all right angles. So we know automatically their angles are congruent. All corresponding angles are congruent. Now let's look at their corresponding sides ratios. I'm going to say let's pair up WX with DA. So WX and DA, let's go ahead and write the numbers for that. 24/6, because this is 24, this is 6. Let's do the same thing. We know that 24 and the ZY over CB is going to be the same thing. We know that's equal. And then let's do the other two sides. AB, that's 4, and XY. So we're going to say 16. The bigger side comes first since the bigger side of this triangle was stated first in both of these ratios. Then we're going to do the same thing here. Always go in that same direction as you went before. So if you start out with the bigger figure and then put it a number in the denominator here from the smaller figure, it's always going to be big figure over smaller figure, big figure over smaller figure. Okay, so 16/4 here. And then again, it's 16/4. Well, all of these right here, 24/6, that's equal to 4. 16/4, that's equal to 4. So this statement of proportionality is the same thing. It is equal to 4. And that means these two figures are similar to one another. So we can make this statement that WXYZ is similar to DABC. And we're done. This is our statement of proportionality right here that we will ask to be found. It says determine whether the polygons are similar. If they are, write a similarity statement. This is your similarity statement right here. This up here is your statement of proportionality. And what we calculated from this statement of proportionality, this right here, 4, whatever your fraction reduces to, in this case it was 4, that right there is our scale factor. And we'll be asked to calculate the scale factor again. So remember that. When two figures are similar, the scale factor comes from the corresponding sides ratio. Okay, let's look at something else. Okay, in our book we have this theorem. It says perimeter of similar polygons. And it says if two polygons are similar, then their ratio of their perimeter is equal to the ratio of their corresponding side lengths. So I'm going to write out that statement. Perimeter of any polygon is just all of the sides added up. So I'm going to start with side AB. So side AB, and then BC, DC, and AD. All of those sides added together. Over the other perimeter of this smaller figure here. So go around it. Let's see, QR. This perimeter over this perimeter, if these two polygons are similar, then it should have the same ratio as their corresponding side lengths. So it should be equal to AB over PQ, which is the same ratio as BC over QR. And then that's the same as CD over RS. And again, that's the same as DA over SP. So just pointed this out that the ratio of the perimeters is equal to the same thing as the ratio of the corresponding side lengths, which is the scale factor of similar polygons. Okay, on this problem here, all of these 6 through 10 deal with this figure over here, these two figures. And it says from the beginning, it says find the scale factor of WXYZ to MNOP. So what it means by find the scale factor of XYZ to MNOP, find how big, see this figure is smaller than this one, how big this one got to go to this one. So your scale factor on this one is going to be something greater than 1. Okay, anytime it shrinks, it's less than 1, or it's going to be between 0 and 1. It's going to be a fraction between 0 and 1. Okay, so let's find the scale factor. To do that, we need to find two corresponding side lengths. So we have here XY, we have as 8, and let's see, NO is another side length that we have. We can figure out its scale factor by placing the bigger number over the smaller number, 10 over 8, because it's going to be bigger than 1 for if we're going this direction. And then just reduce that fraction, which is 5 over 4, and that there is your scale factor. You can write it in decimal numbers, but just keep it as this right here for now. All right, so we figured out the scale factor. The scale factor is actually useful. It can help us in finding the other side lengths around the figures of the polygon that are missing. So on find values of x, y, and z, let's do that down here. So we can say this right here. Let's do the ratio of the corresponding sides. We know 8 corresponds to that side that's 10. 8 over 10, those two sides correspond. And that should be equal to, if these two polygons are similar, let's see, MN, okay, WX. Side WX is 12, so say 12 over X. So here we have a statement of proportionality that is an equation too. We can solve for X by cross multiplication here. So this is how I would do it. Cross multiply, say 10 times 12, that is 120. And then 8 times X, that is just 8X. Now divide both sides by 8 and you get X is equal to 15. And there you go. We're done with that one. We found x. Now y, let's look at this side y is on. That is WZ. WZ corresponds to PM. Let's see, PM, right here. And PM is 10 and ON is 10. That means these two sides, X, Y, and WZ, are going to be congruent too. So we can say right away that Y is equal to 8. So far you can put up here that X is equal to 15. Y is equal to 8. And then Z, well, that's angle Y right here. That corresponds to angle O. So these two angles are congruent. That means Z is going to be equal to 135. And there, we're done with number 7. Now it says find the perimeter of WXYZ. Okay, so WXYZ, we need to know all of the side measurements of that polygon. We already figured out that over here y is 8. So we have 12 plus 8 plus 12 plus 8. Well, for that right there, 12 plus 8 plus 12 plus 8, that all adds up to 40. So there's your perimeter for that one. And then on this one, we know x is 15. Since these two sides are congruent, these two sides in our polygon are going to be congruent, so this side right here is 15. So add up again. You could say 15 plus 10 plus 15 plus 10. And that is 50. All right, now it says find the ratio of the perimeter of MNOP to the perimeter of WXYZ. So now it says go this direction. Find the perimeter of this one to this one. Okay, whoops. So going the other direction, we're going from a bigger figure to a smaller number, which means our ratio is going to be these two as a ratio. So 40 over 50, which reduces to 4 over 5, which is basically the same thing up here. Our perimeter, if we're asked to find the ratio of the perimeter of WXYZ to MNOP, then it would be the same number as we found up here. Just like our perimeter back here, our perimeter of similar polygons theorem stated that the ratio of the perimeters is equal to the ratio of the corresponding sides, and which is equal to the scale factor. Okay, so we're done with that one. Now, last two problems, and I'll be done. On this one, we're going to say, let's find what M and N are, because it says up here the two triangles are similar. Find the values of the variables. Well, we got to look for clues in this triangle to help us figure out what side's similar to what. And what's going to help us most of all are the angle markings on here. So this angle and this angle means that this side opposite of this angle and this side opposite of that angle, those two sides correspond to each other, meaning we can write 6 over 12 as a ratio. And then to find either one, N or M, doesn't matter which one we start with, let's go ahead and find M. Let's state this segment first is corresponds to this segment over here, M. So 5.5, not 55, over M. Solve this. So again, do your cross multiplication and we get 6m is equal to 66. So m is equal to 11. And we're done with finding m. Now let's find what n is equal to. Let's start with, again, the same ratio, 6/12. And since we started out with something on this triangle, let's state n first in the next statement of proportionality. N over, and this side is the corresponding side, 8. Many times you can tell what sides correspond to what just by the way the shape looks. Sometimes you do want to go off the angle markings to help you in figuring what's what. Okay, in this figure, or in this equation that we had up here, m was in the denominator. That's why I said go ahead and do cross multiplication. This right here, n is in the numerator. So we don't necessarily need to do cross multiplication on this. You can if you want. You'll end up with the same value as what I'm about to show you, but in this case, n being in the numerator, the only thing you have to do is multiply both sides by what's in the denominator to cancel that out, get n by itself, and so n is equal to whatever this calculation is, which is 4. And we're done with that one. Okay, let's do one more. Again, let's look at the corresponding angles and their sides to help us figure out what sides correspond to each other. So I'm going to say this angle right here that's marked with a double angle marking, that is the side opposite of that, and that side is the side opposite of that one. Well, since these two angles correspond to each other, these two sides correspond to each other. They're opposite sides. So let's write 15 over 10, and that is equal to, well, again, side opposite of that angle marking and the side opposite of that angle marking, those two are going to correspond. And since we took the side measurement from this bigger triangle first, we're going to write the side measurement from that triangle again first in our ratio over the one over here. Okay, again, we're going to have to use cross multiplication. So 15 times m is equal to 10 times m plus 4. Make sure you write it like this, 10 times m plus 4, because that 10 right there is going to distribute. So now say 15m equals 10m plus 40. And now subtract the 10 from both sides. You get 5m equals 40. Divide both sides by the 5. You get m equals 8. And there we have it. We found our variable that was missing. And we're done. So I hope this helped y'all in understanding a little bit about similar polygons, and we will work in class on our assignment whenever we get back, and I see you next time. So goodbye, everybody.